One can easily ask yourself the question, but why logistics engineering? Is it really necessary? This short session answers this question. The complexity of systems is on the increase. Also, many systems do not adequately solve the use problem for which they were developed. Another thing is that such systems often has a very high cost of both operation and support. When one wants to investigate why the cost of systems is so high, it is often found to be due to the lack of visibility of the various cost contributors during design and development. In the iceberg analogy of cost visibility, only the direct acquisition cost of a new system is visible to project engineers that make the purchasing decision. The other costs that are mostly hidden and unknown includes operations cost, maintenance cost, training cost, test and support equipment cost, retirement and disposal cost, and so on. A very large percentage of the total lifecycle cost of a system can be attributed to operating and maintenance costs. The extent of this operations and maintenance cost is mostly determined by decisions taken during the early conceptual design. Also, the support infrastructure chosen for the maintenance and support of the system significantly impacts on the cost of the system. The figure shows that by the time that the system is manufactured, most of its cost profile for its life has been determined. See the dotted line. And the opportunity to impact on the long-term cost effectiveness of the system is very low. See the hatched profile. The figure shows a rough comparison between a system where supportability gets proper attention during the early design phases, that's the solid line, and one where there is not an early emphasis on supportability, the dotted line. The solid line process has much less supportability problems as time develops. Logistics engineering is part of the systems engineering process and includes the definition of the system, support requirements, the development of design criteria, the evaluation of alternative designs, determining operational and maintenance resource requirements, and continuous improvement of the support infrastructure. Systems engineering addresses all facets of design, manufacturing, test and evaluation, as well as support of the system. One can describe systems engineering simply as good engineering. This is so because it addresses the system as a whole via a top-down approach, and it has a life cycle orientation. This is a well-known diagram in the systems engineering world. The left side is top-down and shows the design and construction phase of the life cycle. The right side is bottom-up and shows the system integration and utilization phase of the life cycle. The shaded area is the part in the diagram where logistics engineering can play a major role. This was the second last sub-session of session 2. All that remains now is to wrap the session up with some additional aspects of logistical analysis.